This video will cover the startup and typical operation of the AAT in the field. We will take you through the startup process and through setting the orientation to familiarize you with these two important aspects of using the tool. To get started, go ahead and power on the AAT by pressing the On button located in the lower right front of the AAT. After several seconds, you'll see the SunSight logo, and in the lower right corner of the vertical or left display, you'll see the letters COM. This means that the AAT is testing all of the internal components of the device and making sure that everything is working properly. Next, COM will be replaced by a flashing GPS to let you know it is attempting to locate GPS satellites. Signal acquisition in ideal conditions should occur within 20 seconds, and success can be verified by observing the flashing GPS indicator transitioning to a flashing AZM indicator. Note, if the AAT has been moved a long distance since the last power down, it will take longer for it to calculate its GPS position. The AAT begins searching for its GPS location based on the last position it found. So if you turn off the AAT in Seattle and turn it on in Miami, it will take longer by about 3 to 4 minutes the first time it is powered on in the new location. Once the AAT begins flashing AZM, it means that it's attempting to calculate a GPS-based Azimuth solution. Normally, within 90 additional seconds, the AZM indicator will stop flashing and remain solid. This indicates that the azimuth has been acquired, and the tool is ready to start taking and capturing measurements. Keep in mind that anytime the AAT has calculated an azimuth solution, you will see the azimuth number displayed on the unit. If the tool does not have an azimuth solution, it will not display anything. Furthermore, it only displays an azimuth when it's confident that the solution is accurate. Given that, you can have high confidence that a displayed value is accurate to within the stated specifications of the tool. Once you've acquired an azimuth solution, and before taking any captures, you need to set the orientation of the tool. The orientation of the tool is very important, since it uses that value to display correct values for azimuth, tilt, and roll. There are 4 possible orientation values for the AAT. AAT faces left, AAT faces back, AAT faces right, and AAT faces front. To determine the correct orientation, complete the following question. When standing behind the antenna, which way are the AAT displays facing? Left, back, right, or front? To set the orientation, from the main menu, select Set Orientation. Scroll through the 4 options using the up and down arrow keys on the front panel, pressing the Select key once the correct orientation has been set. Once selected, you'll notice the orientation letter designator on the bottom of the vertical display change to reflect the selected value. It will display L, B, R, or F for left, back, right, or front, respectively. By looking at this designator, you can quickly tell what the currently selected orientation is and adjust it if necessary. The reason that setting the correct orientation is important is so that the tool can properly differentiate between tilt and roll, as well as to properly adjust the azimuth solution. For example, when the AAT is facing left, tilt would be measured by the inclination of the tool as shown, whereas roll would be measured by the inclination of the tool on the other plane. However, if the orientation of the tool were set to back, when the tool displays were actually facing left, the tool will reverse the tilt and roll values. Fortunately, any azimuth solution value shown when an incorrect orientation is set will be more apparent, since it will be either 90, 180, or 270 degrees off. Let's look at an example again, only this time we'll see how azimuth is affected. Assume the AAT is mounted with the displays facing left as shown. With the orientation set to left, the azimuth reads as 0 degrees, which is correct. However, if the orientation were set to back, the AAT would assume it is mounted as shown and would therefore calculate the azimuth as 90 degrees. If the orientation were set to right, the AAT would assume it was instead mounted like this, and would calculate the azimuth as 180 degrees. Finally, if the orientation were set to front, the AAT would assume it was mounted like this, and the orientation would be calculated as 270 degrees. Given the large differences from the target azimuth, it is easy to detect an incorrect orientation by simply looking at the azimuth reading. If you notice this condition when you are preparing to capture, simply return to the main menu and select the correct orientation, and the measurements will immediately be adjusted to their correct values. One final item of note is that the orientation refers to the direction the AAT displays are facing in regards to the radiating direction of the RF antenna and not the side of the antenna it is mounted on. Recall that the AAT can be inserted into the mounts with the displays facing either direction. For example, assume that the side mount is attached to the left side of the antenna, and note that the AAT can be inserted into the mount with the displays facing left or right. So be sure to always set the orientation based upon the direction that the AAT displays are facing. You are now ready to select the sites and perform captures. If you have not yet created any profiles, you should first review the training videos on creating and managing profiles using the AAT keypad and AAT capture modes for additional information before proceeding. This concludes the video on keypad startup and operation.